Okay, welcome to our final lecture in our Mesoamerica Interpreter Foundation Tour lecture series. This is really exciting to me. I am so happy that we're able to have Dr. Benjamin Jordan address us this evening. Dr. Ben, as his students call him, is a volcanologist and geological oceanographer. He earned his BS in geology with University of Honors and a minor in physics from Brigham Young University in 1999. He earned a PhD in oceanography from the University of Rhode Island's Graduate School of Oceanography. Where he studies Central American volcanic history and deep sea ash deposits. He also served as a scientific crew member aboard the ship RV Melville during the 2001 Glimpse scientific expedition to the Central South Pacific, mapping and sampling deep sea volcanoes between Tahiti and Rapa Nui, which is Easter Island. Upon completion of his PhD, he became an assistant professor of geology at United Arab Emirates University in the Middle East, after which he taught at Brigham Young University, Idaho for 5 years. He's been at the Brigham Young University Hawaii campus since 2012, becoming a full professor in 2018 and dean of the Faculty of Sciences in 2022. He has a geologic and/or oceanographic field experience in 38 U.S. states and 31 countries. He's a fellow of the Explorers Club and a member of the Geological Society of America, the American Geophysical Union, and the International Association of Volcanology and Chemistry of the Earth's Interior. He's the author of 4 books and is first or contributing author of many peer-reviewed articles and presentations. He's also served as a reviewer for multiple academic journals and organizations, including the National Science Foundation and the journal Geology. So with that, I want to go ahead and turn the time over to Dr. Ben. But remember that if you have questions along the way, feel free to post those in the chat box. And then at the end of the presentation, Dr. Jordan will be able to respond to those. And with that, let me turn the time over to Dr. Ben.
All right, thank you very much. Aloha, everyone. I'm happy to share some thoughts and insights on this topic. To start off with, though, I want to talk a little bit about my title, Potential Volcanic Activity. So emphasizing the word potential, because as has been talked about and discussed in some of the previous lectures, since we don't really know exactly the geographic location where the Book of Mormon took place, we don't know for sure if what I'm going to discuss, the events in 3rd Nephi chapter 8, were actually connected to a volcano or volcanic activity. This is just one interpretation, one idea that I and many other scholars think is possible. And so I hope to just kind of discuss some of those things that I find intriguing in the discussion and the description in the Book of Mormon relative to what we now know through modern research of volcanic activity. So to start off with, though, I want to discuss a principle or bring up a principle that's fundamental to understanding geology in all contexts, whether that's in volcanology or sedimentology or paleontology. And it's this idea known as the principle of uniformitarianism, originally attributed to James Hutton. The basic idea, we'll often quote and say that the present is key to the past. So in other words, the processes that we see today, landslides, volcanic eruptions, earthquakes, floods, those types of processes that we can observe in the present produce geologic evidence or deposits that fit or match with things, they're deposits that we found in the past. That's important because it means that we can make sense of the past. If the processes that occurred in the past were different than the processes that occur today, it would be impossible to figure out and piece together a history of the Earth. So just to start off with an example, I like to use this one. So this is a picture that I took a few years ago in southern Utah near St. George. And this is basically rock. You can see that it has this interesting pattern on it. Well, these patterns are interpreted as mud cracks, fossilized mud cracks. And if we compare those with modern day mud cracks from the same area, but these are modern, you can see that there's a very clear relationship between these two. Now, this is important because by seeing something like this, it actually helps us to identify environments of the past. So one of the things that's interesting in this image is that over here on the left, you'll see is there's no pattern. And that's because that's a dinosaur footprint. When I was growing up as a kid, I loved dinosaurs. Well, I still love dinosaurs, but I used to read any book I could get my hands on about dinosaurs. But back in the 1970s and early 80s, honestly, we didn't really understand that much. And so every book that I read, whether that was a picture book or a thick book or whatever, all said the same thing, that dinosaurs were big, fat, slow, stupid, and they hung out in swamps all day. Well, by applying this principle of uniformitarianism and looking at these two figures, we know that typically large-scale mud cracks like this occur in dry desert environments, much like southern Utah is today. And so what this tells us is that idea that dinosaurs only hung out in swamps is incorrect, that dinosaurs were living and thriving in very dry desert environments as well. And so today, from doing similar things, we know that dinosaurs existed in all the similar types of environments that we see on Earth today. Now, why do I bring up dinosaurs? Well, because they're cool, but also because it helps to set the stage for what I want to talk about. When we look at the Book of Mormon, and we look especially at 3rd Nephi chapter 8, and we read through the descriptions, if we're going to accept that the record that is recorded there is real, that is telling of a real event, then we have to be able to look at the description of those events and match that with our current understanding of the same type of events that would occur in the world today. And so with that in mind, let's start first by talking about what is a volcano. I think if I were to ask that question to anybody, most people know what a volcano is, but to exactly define it, they might struggle. So it's really simple. A volcano is basically just a hole in the surface of the earth through which lava is ejected that can escape from the interior. So here's some examples of that. This one in particular is actually from Central America. This is Messiah Volcano in Nicaragua. Here's San Cristobal Volcano also in Nicaragua. That are two examples from the Central American area, as well as some of the photos from Kilauea's various eruptions. Now, if we look at a map of the world, in this particular image, all of the red dots, they're very fine and hard to see, but there's quite a few, and you can see that all these red dots, those represent known areas of active volcanism or actual volcanoes. And if you look carefully, you can see that most of those volcanic or those volcanoes or volcanic areas, they are in linear in their geography. They tend to form these long lines here through Central Africa, here along the western side of South America, along the northwest Pacific coast, along the North Island of New Zealand, up through Indonesia and the Philippines, the Marianas Islands. There is a pattern to them. And the reason there's a pattern is because the Earth has a hard outer shell, much like an egg here, that is broken. And so it has this outer layer known as the lithosphere. And that layer has broken into regions that we call tectonic plates. And so at the boundaries of those plates is where there is access for magmatic material, magma to reach the surface easier than trying to punch its way through the middle of plates. Now, there are exceptions. For instance, I'm here in Hawaii, which is a hot spot, and where magma has melted its way directly through the middle of a plate, but by and large, most volcanoes occur along the boundaries or edges between the plates. And that's actually very important when it comes to talking about volcanism in Central America. So if we look at another version of this, all of these red dots represent both volcanoes and earthquake epicenters as recorded over the years. And if you draw a line and you can connect these dots of epicenters and volcanoes, if you do that, you come up with basically the boundaries of the plates. So here's the African plate. If I follow this line of dots representing the epicenters and the volcanoes, that gives me what's known as the African plate. If I look at South America, same thing. The dots run along here. They cut across over here into the Atlantic and back up, and I have the South American plate. If you'll notice, especially over here in South America and Central America, there's a lot of activity, a lot of earthquakes, and a lot of volcanoes. Now, the reason that there are a lot of volcanoes at the boundaries has to do with these plate tectonics. So I don't have time to go into all the details as to why magma forms in different places, but the two main things that I wanted to point out was that magma doesn't form really deep inside of the earth, as it's often portrayed in movies or in popular culture. Magma is really a shallow thing that forms relatively near the surface of the earth, usually right at the base of that layer known as the lithosphere. That's where the magma forms. Most of the time, that magma will form where the rock will melt because of the loss of pressure. Just like if you're at a higher altitude, it's easier for water to boil at a lower temperature. The same thing happens inside of the earth as rock is near the surface where there's lower pressure. But there are places where the lithosphere plate will actually, we say it subducts and it sinks and is pulled down into the earth. And in those places where that plate sinks, magma is generated because there's water that comes out of the sinking plate into hot rock above it, causing melting. If any of you are from places where there's a lot of ice and snow in the wintertime, they'll put salt. The road workers will put salt on the road because the salt, when it combined with the ice lowers the melting temperature so the ice will melt. Well, the same thing happens inside of the earth where water added to hot rock will lower the melting temperature of that rock and you'll get a magma. But what's really important about this is that water, so here's the example of here's the plate that's going down. The water is coming from the ocean. So this seafloor on the plate is moving. It's been for millions of years slowly. The rocks will absorb water into their molecular and mineralogical structure. So you'll get what are called hydrated minerals because those minerals will actually trap the water within their structure. As that plate subducts, the pressure builds, the temperature builds, and that water's not happy. So the water will come out into the overlying rock above it, where it basically causes that rock to have its melting temperature lowered and a liquid magma is generated. But what's really important here is that what happens to the water after the rock melts. That water doesn't just sit there or go away, just like if I put salt on ice and that ice melts, the salt has to go somewhere. So the salt becomes dissolved in the liquid of the melting ice. In this case, the water is dissolved into the melted rock, into the magma. And so the magma doesn't just form, but it absorbs and dissolves the water that made it into itself. Now, there's a reason you'll see why I'm giving this little kind of geologic background about volcanoes and how volcanoes form in subduction zone areas with this infiltration of water. Okay, if we look at Central America, now again, like Dan Peterson in his presentation talked about that he's open-minded. We don't know exactly where the Book of Mormon lands were. That's true. And so I'm open-minded enough that if people want to talk to me about the Heartland model or they want to talk to me about other models, I'm more than happy and willing to listen. But because of some of the things that I'm going to present to you here, I definitely lean towards Central America as the most likely place where the Book of Mormon lands would have been. And if we look at the Central American area, we see here in southern Mexico, there's a long line of volcanoes that extends down in through southern Mexico, Guatemala, into Nicaragua and Honduras. And there's many, many, many volcanoes that run along this region. And the reason why those volcanoes are there is because there is a tectonic plate known as the Cocos Plate that is subducting to the northeast beneath the continental lands of Central America. And that subduction goes down, it releases water that generates magma. That magma then rises to form the volcanoes that we have in Central America. To give you kind of an example of this, this is a picture I took this last February. I was in Guatemala. The picture that is the point of view, the location that I've taken this picture from is on Fuego volcano in Guatemala, and I'm looking to the southeast, and in front of me, so I'm standing on one volcano. Here is the Aqua volcano. In the distance is Pacaya volcano. You can see the steam coming out. And so I'm basically just looking down this line. And so if the air was clearer, I would see even more of these volcanoes that are lined up. So they form in a line because the subduction, the contact of the subduction is in a line. And so you basically have this line of magma rising above the subducting plate that creates these linear features of volcanoes. Okay, so with that background that I've given to you, hopefully what I'm going to talk about now will be a bit more understandable, and you'll see some of the interesting things as described in 3rd Nephi chapter 8. Now I have to give complete full credit to much of what I'm going to talk about to Dr. Bart Koalas, who was one of my professors when I was a geology student back at BYU. He's now retired, but in my opinion, he wrote the definitive article and discussion on this topic. It was printed in BYU Studies in volume number 37 in the 1997-1998 period of time. This is his article in the 30th and 4th year, A Geologist's View of the Great Destruction in 3rd Nephi. I can't recommend this article enough. He does an amazing job of taking point by point observations that have been made in volcanic eruptions with the descriptions that are in 3rd Nephi 8. So much of what I'm going to be talking about is coming from his discussion. So to begin with, though, let's read some of what's said in 3rd Nephi chapter 8. And it came to pass, there arose a great storm, such an one as never had been known in all the land. And there was also a great and terrible tempest, and there was terrible thunder, insomuch that it did shake the whole earth, as if it was about to divide asunder. And there was exceedingly sharp lightnings. And the city of Zarahemla did take fire, and the city of Moroni did sink into the depths of the sea. And the earth was carried up upon the city of Moroni, that in the place of the city there became a great mountain. And there was a great and terrible destruction in the land southward. But behold, there was a more great and terrible destruction in the land northward. For behold, the whole face of the land was changed. And the highways were broken up, and many smooth places became rough. And many great and notable cities were sunk, and many were burned, and many were shaken till the buildings thereof had fallen to the earth. And there were some cities which remained, but the damage thereof was exceedingly great. And there were some who were carried away in the whirlwind. And thus the face of the whole earth became deformed. And behold, the rocks were rent in twain. They were broken up upon the face of the whole earth, insomuch that they were found in broken fragments and in seams and in cracks upon all the face of the land. So Bart basically put together a bulleted list of of these descriptions that took place are of the description that takes place in 3 Nephi chapter 8. So we have a great storm, terrible tempest, thunder, shaking of the earth, lightning, burning of cities, so on and so forth. So I will touch lightly on some of these. Some of these are very obvious. If you're going to have large earthquakes, you're going to expect highways and cities and buildings to be broken up or destroyed. But there's some specific things that I want to emphasize that are rather unusual and would have been almost, if not almost unknown, entirely unknown at the time that Joseph Smith translated the Book of Mormon. And one of those is that this darkness, this thick darkness that took place, that there was palpable darkness, and yet fires could not be started. That even though the wood was very dry, you could not start a fire. That's a highly unusual circumstance, and there's not many natural phenomenon that can explain that particular situation. That coupled with things like you couldn't start fires, and yet you had cities that were burned. So that seems to be somewhat paradoxical, that how could you have those two things? They seem contradictory. I also am going to talk a little bit about potentially how do you change the whole face of the land and what that may mean. And maybe some people's interpretations, I think, are a little bit that's misunderstood. But we'll go through some of these things as I go. So back to this discussion about the water that caused magma to form, but then dissolved into the magma. Now, I live here in Hawaii, where we have hotspot volcanism. This is an image of, in 2018, this was the neighborhood of Leilani Estates on the Big Island, where a large fracture opened up in the earth and lava started pouring out, destroying homes in the neighborhood. It was a significant event. But the thing to point out was that this event did not include large-scale violent explosions, at least not in this area of the eruption. And that's because the lavas that erupt in Hawaii are low viscosity. They also are relatively low in their gas or water content. And that's because the way that the magma forms here in Hawaii is not because water was added and caused melting. It's because the rocks are rising up beneath the Pacific plate where Hawaii is. They lose pressure and they'll melt because of that loss of pressure. Whereas in places where you have subduction, that magma, because it's been supercharged with the water that caused it to form, when that magma reaches the surface, the expansion leads to very, very large, violent explosions. Like this one, this is a Sakurajima volcano in southern Japan. And you can see that there's lots of ash falling from the clouds. The clouds are extending up. This is a very violent, explosive situation, but it's only that way because of the subduction process that put water into the magma so that it's basically a charged ball of a bomb of steam when it reaches the surface. Just like when you open a bottle of Sprite or Coca-Cola or something, when you open it, it releases the pressure, and so the dissolved gas fizzes out and it can spray out of the bottle. It's the same thing that's happening in a volcano, only it's mostly water vapor that's coming out as steam and explosively expanding expanding largely to cause an explosion. This is important because at the time of Joseph Smith, none of this was understood. Lots of people knew obviously there were volcanoes in Hawaii. There were volcanoes in Europe, such as people all knew about Vesuvius and Pompeii, other volcanoes around the world, but nobody understood the mechanism for why some volcanoes were explosive, like in Central America or in Europe, versus volcanoes that weren't explosive, such as the ones in Hawaii. It's all about the water content. and the water content is all about subduction. So what happens as the magma is coming up to the surface, it loses pressure. Like I said, in the case of a soft drink, the gas bubbles come out, they form a froth, and then they expand very rapidly to explode out and spray out of the mountain, out of the volcano, forming clouds of ash and debris. And as I'll talk about in a little bit, pyroclastic flows. It's again, it's identical to what's happening inside of a soft drink when you release the pressure, only this is on a much, 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 much larger scale. Okay, pyroclastic flows. So the single most dangerous thing associated with volcanoes are pyroclastic flows. So these are large clouds of ash, of lava. Oftentimes when we see an image like this one and we see the clouds of ash, it looks like dust clouds or a dust storm. What you can't see or get a very good feel for is that these pyroclastic flows, or what we now call pyroclastic density currents, are very, very high in temperature. In fact, they're about 700 degrees Celsius or over 1,000 degrees Fahrenheit. And so you have these clouds that rush down the sides of the volcano. They're 700 degrees Celsius. They move at about 200 kilometers an hour. They're semi-solid, filled with steam, poisonous gases. Essentially, if you get caught in one of these, your chances of survival aren't quite zero, but they're pretty close to zero. There have been, throughout history, there's been a very, very small handful of people that have survived, but it has not been a pleasant, it was not a pleasant thing. Most people, if you're caught in a pyroclastic flow, you're not going to make it. So, not to pick on Hollywood too much, but anytime you see a Hollywood movie in which somebody is caught in a pyroclastic flow and they make it out, especially if they make it out without any serious injury, that's just Hollywood magic. It doesn't work that way. As an example of this, here's an image. This was taken of the aftermath of the El Chichon volcanic eruption in Mexico in 1982. So El Chichon is a volcano that lies in Central America. And you can see that this is concrete that had rebar in it. And most of the concrete has been broken or swept away. And the rebar has been completely deformed and bent in the direction of the flow of the pyroclastic flow. Now, one of the most dramatic examples of what a pyroclastic flow can do to a community happened in 1902 on the island of Martinique in the Caribbean, when Mount Pelée, is the volcano in the background, you can make out some of the steam and gases coming out, erupted, destroying the town. Now, there's another important aspect in all of this related to the Book of Mormon when it comes to this event. Up until this event, nobody really understood the nature of volcanoes. There were the beginnings, especially in Italy, looking at the eruption of Vesuvius. Many people were aware of the eruption in 1883 of Krakatau volcano in Indonesia. But as far as trying to understand the nature and the events that take place when a volcano erupts, the birth of modern volcanology really kind of begins here in the city of St. Pierre that was destroyed by Mount Pelée volcano in Martinique. So I say that because if we're going to review the record that's recorded in the Book of Mormon and look at a time when Joseph Smith in the early 1800s was writing this description, he wouldn't have had access to the understanding of what takes place during a volcanic eruption that we take for granted today. And in fact, most people would not have had access to the kind of descriptions and understanding that we have that begins with this event in 1902. So in 1902, this beautiful city of St. Pierre was built at the base of a volcano, Mount Pelée. On the 5th of May in 1902, the volcano erupted. And when it did, these violent pyroclastic flows ripped through the town. completely devastating and destroying the town. Well over 20,000 people were killed in less than 24 hours as these pyroclastic flows came through. And you can see that the city was destroyed through both burning, all the roofs and things are gone, but also it looks like it's been flattened. And that's because, again, these pyroclastic flows, as they move through an area, they're semi-solid. So it's like a semi-truck bursting through a wall. We have an example of this from Central America as well. In, let's see, 1524, the village of Leon Viejo here in Nicaragua was destroyed in a similar eruption from this volcano in the background known as Momotombo volcano. This image here this is a picture of a Catholic church, and all that's left is this part of the walls. Now, an interesting thing that you can see is that the walls are all broken at the exact same height. And the reason for that is because when Momotombo first erupted, it didn't immediately send pyroclastic flows that came down the volcano through the village. Instead, it was erupting in a way where the violence of the eruption was able to throw pumice and ash very high in the air for a long period of time. And so that pumice and ash could fall, much like snow, and it buried parts of the village up to the height of that wall. So it basically raised the level of the land, much like snow would raise the level of the surface to that height. And then at that point, as the eruption, the column of ash and debris collapsed into pyroclastic flows, those pyroclastic flows traveled over the surface of this ash and pumice at that height and basically truncated all the tops of the buildings all at the same height. Now, in the case of Mount Pelée, that didn't happen. In this case, the pyroclastic flows came straight down, and so you can see that the walls here are not all the same height because they were just smashed by the pyroclastic flows as they came through without having kind of any base layer that would support the lower parts. So here's some photos that were taken in the aftermath. So I say this was the birth of modern volcanology because when this happened, Saint Pierre was known as the Paris of the Caribbean. It was a French colonial town. Many tourists would come from all over to visit it. It was a beautiful area. And so this was a shocking thing to the world when this occurred. And so there were rescue efforts that were organized to try and go and rescue individuals. There were many scientists as part of these rescue efforts. There were also groups of scientists that were collected and sent to try and figure out what had happened and what had taken place. Unfortunately, when it comes to the rescue efforts within the town itself, there are only 3 survivors that are known of the 25,000 plus people that were there. 3 survivors. One famously was a prisoner that was in a jail cell that was beneath the ground, so that the pyroclastic flows passed over the top of him. However, because of the heat, he was still severely burned, grotesquely scarred over his body. He eventually immigrated to the US, where he was hired by the Barnum and Bailey Circus as a sideshow, where people would pay money to go in, and he would sit on a chair with his shirt off, showing the scars of his burns, and he would tell the story of his survival. The other 2, one was a farmer that was not, I believe, was not directly in the town, but was nearby. And then there was a young teenage girl who survived and was interviewed about the eruption. But what happened to her after that interview, no one really knows. There's no record that I'm aware of that told her story after that. But you can see that the town went from this thriving, beautiful, beautiful city to complete and utterly destroyed and destructed. And again, you can see the broken buildings, the debris. Here's an image from that time from the first rescuers that showed up. You can see people buried under rubble. You can see the collapsed buildings. You can see the charred and burned wood that all came from this event. Now, again, this happened in 1902. well over 70 years from the publishing of the Book of Mormon. But this is where the first kind of real detailed descriptions and scientific understanding of the effects of a volcanic eruption began. In the Book of Mormon, in 3rd Nephi chapter 8, we read of not just large storms, but of large amounts of lightning. Well, lightning is a well-known phenomenon that takes place during a volcanic eruption, because as the ash is erupting into the air, it builds up very large static electric charges that release themselves as lightning bolts. And here are a couple of examples of very dramatic eruptions, one in Chile and one in Iceland, showing the incredible amounts of lightning that can be released. Even in smaller eruptions, lightning can be seen. I've seen lightning in eruptions on Kilauea, very, very small, faint ones that occurred when the lava entered the ocean and there were steam explosions. Very small scale, but still built up enough static electricity for small flashes of lightning. But when you have a large eruption, you have a large potential to create massive lightning bolts. Now, another thing that can happen, if you have a high mountain that's covered in snow, for instance, that eruption, the heat from that eruption can cause the snow to melt, creating floods of water that mix with the ash as it comes down the volcano and creates basically large mud flows or mud floods that are known as lahars. And so these are very common at high altitude volcanoes with ice caps. However, they're also very common in tropical regions that have heavy rain, because when this ash goes into the atmosphere, it's very common to also have very large rainstorms that can occur, because the rapid rise of heated air into the air lifts the surrounding air with it. And that because of that surrounding air, if it's hot and humid in a tropical climate, is raised to higher altitude, it cools and it condenses, and then it precipitates as rain. And so oftentimes in tropical regions, you can have heavy rainfall associated with a volcanic eruption. And that rainfall can then mix with the ash as well and produce these mud flows, these lahars. When Mount Pinatubo erupted in the early 1990s in the Philippines, there were massive lahars that were formed and produced because of the rain that was generated during the eruption, and because, unlucky for the Philippines, at the same time that the eruption occurred, there was also a hurricane or tropical storm that arrived at the same time. Now, lahars can travel hundreds of kilometers from the source. And these lahars are basically walls of mud that will destroy and bury anything in their path. If there is a village, if there was a town, if there are communities of people, these mud flows will completely bury anything that they reach. Okay, so in talking about these various things, the pyroclastic flows, the lahars, all of these things can match well with the descriptions that we see in 3rd Nephi chapter 8 of cities being buried, humans being buried, the large whirlwinds that can occur because a pyroclastic flow is as it pushes down is very violent and create vortexes within the surrounding atmosphere. Storms are generated, and so it's not unheard of to have things such as whirlwinds or tornadoes that are associated with volcanic eruptions. And so all of those things can occur. But I think, to me, the most interesting thing, and the thing that points to the potential that 3rd Nephi is describing a volcanic eruption, is this, where it says, "And then behold, there was darkness upon the face of the land. And it came to pass that there was thick darkness upon all the face of the land, insomuch that the inhabitants thereof, who had not fallen, could feel the vapor of darkness. And there could be no light because of the darkness, neither candles, neither torches, neither could be fire kindled with their fine and exceedingly dry wood. so that there could not be any light at all. For so great were the mist of darkness which were upon the face of the land. And it came to pass that it did last for the space of 3 days, that there was no light seen. At the time of Joseph Smith, there had been an eruption in 1883 in Indonesia that much of the world had known about. But most of the descriptions of what had happened during that event didn't really come to light until many decades later, as people began to read through journals and record the information that was there. Many of the eyewitnesses that survived the 1883 eruption of Krakatau had descriptions that are very similar to this next one that I want to show you. And it was this one. Someone burst in shouting, "Shut the doors, shut the doors." Suddenly it was pitch dark. The last thing I saw, the last thing I saw was the ash being pushed up through cracks in the floorboards like a fountain. There was still deep darkness. We couldn't light a fire, as matches went out immediately. At last, the head boy, the only remaining male servant, managed to start a small fire. Now, the reason that you can have very dry wood and yet not be able to have fire start is because fire requires oxygen in order to burn. And the amount of oxygen necessary for materials to burn is more than the amount of oxygen that's necessary for humans to breathe. And so when you have a pyroclast that come through and it carries with it volcanic gases, those gases displace the normal proportion of oxygen in the atmosphere. In addition, the ash also basically takes up volume of the air so that there's less oxygen. If I fill the air with ash, if I fill it with gases, then that's going to displace the necessary oxygen in order for fire to take place. Here's an example of just kind of show the contrast. This is Mount Redut volcano in Alaska in eruption, and you can see downwind from the eruption. This is not a large eruption. This is rather small. But you can see this plume of ash and the darkness that exists where this ash cloud is. I'll also point out, interestingly, down here at the bottom is looks like a lahar deposit, probably from the ice and snow that melted and then flowed down at the base of the volcano. This is an example of someone who took a picture during the Mount Pinatubo eruption in the Philippines. This is at midday. This is around noon when this photo was taken. And you can see that without the flash of the camera, it would be pitch black, completely dark. This is an example from Yakima, Washington, at the time of Mount St. Helens eruption. This is 85 miles away from the volcano in the middle of the day, and you can see the amount of ash and the blanket and how much it would darken everything when it occurred. In addition to this darkness that's caused by the ash, that ash, once it falls, it puts a weight on the roofs of buildings. And so many buildings will collapse because of the weight of that ash, because as fine as it is, if it builds up thick enough, the weight of it will break through and cause collapses of buildings, crushing anybody that's inside. In many volcanic eruptions, people are killed because the ash builds up on the roof of the buildings that people are sheltering in, and they are buried from that collapse. Another thing that happens in a large-scale eruption is that as volcanoes erupt, they have a magma chamber, which is the source of their lava, that comes out, and as it does and it empties, it basically leaves an opening, an unstable opening, and so the ground above it will collapse inward and downward, forming what we call a caldera. So a good example of this is Lake Atitlan in Guatemala. So this large lake takes place in what was an ancient, or what was a volcano anciently and is now a deep depression. One of the things that's interesting about this that I like to point out, especially to my students, is so this is a view from up high, this is a view from the surface of the lake. And you can see that here's a volcano and here's a volcano. Here's actually a smaller volcano. But these volcanoes are all part of one large volcano, the large volcano that used to exist here, but then collapsed downward to become the lake. So a lot of people would come here and not realize that these volcanoes that they're looking at are just smaller volcanoes on top of what was a much larger, much more massive structure that collapsed in some previous eruption. So if we look again at 3 Nephi chapter 8, and there was a great and terrible destruction in the land southward, but behold, there was a more great and terrible destruction in the land northward. For behold, the whole face of the land was changed because of the tempest and the whirlwinds and the thunderings and the lightnings and the exceedingly great quaking of the whole earth. So the thing that I'd like to point out here, and this is my interpretation of this, is that when I was growing up, when people would talk about the destruction in 3 Nephi chapter 8, they would often talk about how the whole face of North and South America was changed. Even as recently as when I was an undergraduate, I met an individual who would talk about how Y Mountain to the east of campus, that those mountains rose up during the destruction of 3 Nephi chapter 8. But I think if we take our modern understanding that most people look at regarding the Book of Mormon and its much more limited geographic area, when we talk about the whole face of the land, I don't think that we're talking about even the entire face of the land that the Nephites and Lamanites occupied. As I read this, it seems to me that the whole face of the land that was changed was the land northward. I'm not an expert in linguistics or in this particular area, but again, as I read this, but behold, there was a more great and terrible destruction in the land northward. For behold, the whole face of the land was changed. To me, personally, that's applying directly to this land northward, not necessarily all of the lands, pointing to a much more limited impacted area. If we look at some modern eruptions, such as Mount St. Helens, we have the mountain. There was a massive landslide that the mountain broke apart. Initially, the eruption began with this massive landslide, and then the eruption, the lava that was erupted afterwards. We now know in volcanology that having a volcano erupt beginning with a landslide is a very common event in volcanoes. This is an example of Mount Shasta, and you can see this foreground in front of me would have been relatively flat, but all of these little hills, and some of them even larger ones, were formed when a large landslide in some previous eruption at Mount Shasta collapsed, producing what we call hummocky terrain. So all of these bumps, so areas that would have been flat and level are now uneven, and in some places have relatively large structures or hills rising out of what would have been flat and lowlands. We see the same kind of terrain in parts of Central America, and especially in the areas of volcanism. This is central Nicaragua. In addition, when we look at the rocks in that area, we find that these volcanic rocks are filled with debris of pieces of larger rock or pumice and compacted ash. Now, I really like this photo because to me, even though this is clearly taken from the same point, if I was going to describe something as having the whole face of the land being changed, I think this is a pretty good example of that without having to have Y mountain sized mountains rise out of the ground. If I completely wipe out the forest, if I fill in the lakes and the streams, if I remove half of the volcano or the mountain, if I came here and this is all I knew, and then I came back later and this is what it looked like, I think I would probably say, yeah, the whole face of the land was changed. So that's from my perspective, that's the way I interpret that. Okay, so to kind of end off with a couple of things, just again, most of this is all from work that was done by previous scholars, especially Bart Koalas. But I want to just talk a little bit about my own little kind of contribution to this idea. And that is that I was approached many years ago, actually after Bart Koalas's publication. And the question was, is there modern evidence for a large volcanic eruption to have taken place around the time that Christ was crucified? So not to take too long about it, but I went into the literature and I dug in to see what evidence we had. And one of the things to look at is if you're going to detect a large scale volcanic eruption in the past, because of surface erosion, sometimes it's hard to preserve things. But if you can have a large enough eruption that the gases, especially hydrogen sulfide and sulfur dioxide, reach high altitude above what's known as the tropopause, then that can be carried to the poles, to the North and South Pole, where it will combine with precipitation, snow, and fall and be trapped as a chemical layer within the snow and the ice. Now, the closer you are to the equator, the larger the eruption has to be because the tropopause is not at the same altitude everywhere on Earth. It's actually higher near the equator and lower near the poles. But if you can get an eruption large enough, then you can transport some of that material up to the higher latitudes, where it can then fall with the snow and then be collected within the compacted ice. So this is an image of an ice core, what it looks like. You can see that it has layers. These layers represent the annual snowfall for the season. And within it, you can also see that there are these bubbles, that there are gas bubbles. These are bubbles of atmosphere that were trapped in the compacted snow. So is there evidence? So what I was able to find was that from this ice, a couple of ice cores that were drilled in Greenland, is that there is this spike in acidity caused by likely sulfur compounds around 40 AD or 40 CE. So there's this one. So that's given the error is plus or minus 30 years. So this would be well within the period of time of Christ's crucifixion. Another ice core in Greenland has a similar spike around 47 AD, plus or minus again 30 years. And so the short answer is, yeah, there is evidence that there was a large enough eruption that at somewhere on Earth. Now, do we know exactly where they occurred? No, we only know that these would have been produced by a volcanic eruption somewhere on Earth, but they definitely occurred within the margin of error within the period of time of Christ's crucifixion. However, here's the caveat. There was also within this period of time a very large scale volcanic eruption that is very well known, and what most researchers basically ascribe these two volcanic chemical spikes in the ice to, and that is the eruption of Mount Vesuvius that destroyed Pompeii in 79 AD. So, was this Pompeii? Was it an eruption in Central America? There's actually no way to really know, but because most scholars recognize the eruption of Vesuvius, they basically ascribe this record to that eruption. However, the point to take away though is that because the margin of error is plus or minus 30 years, and there's no way to know whether this was Vesuvius or some other volcano, maybe even not even one in Central America, it could have been Indonesia. The point is to say that there's no evidence of a volcanic eruption at the time of Christ's crucifixion doesn't work, because there is. We just don't know exactly which volcano might have produced this record. We do know there is evidence for a volcanic eruption around this time in Central America from Volcan Tucano, sometime between 25 AD and 72 AD. located here in Central America, well within what was known as the Maya high cultural area at this time. So there is even evidence that within this area there were volcanic eruptions. For reference, this is Lake Atitlan right here. So this is what it looks like today. I think if most people saw that, they wouldn't even realize that it's a volcano, which then gets to the question of like, well, if there were these active volcanoes in the Book of Mormon lands, why don't we have more written about them? Well, the same argument could be said, well, if the Book of Mormon took place in the heartland of North America, why isn't there really any discussion of snow? And I think partly because the writers of the Book of Mormon were focusing on the spiritual messages that they were trying to convey, and that and then the abridgment made by Mormon, he was emphasizing what the Lord wanted him to emphasize, not just the everyday background life of what was going on. However, there's also evidence that during the period of time covered by the Book of Mormon, specifically the Nephite, or I should say the Lehite period of time, the Mulekite period of time, most volcanoes in Central America were pretty quiet, that they weren't as active as we see them today, because volcanoes often go through cycles on the order of thousands of years of their activity. And so to have a very large volcanic eruption surprise the Nephite and Lamanite peoples wouldn't necessarily be surprising. Okay, one last thing to finish up, because I know there's the trip to Central America. I just thought I'd kind of give a little bit of a geology guide. So if we look at Central America and we overlay a geologic map, these different regions represent different types of rocks. So igneous rocks would be related to volcanoes. Sedimentary rocks would be related to things like sandstone and limestone and those kind of things. And so if we look at the area, specifically this area where the Mayans were most concentrated, you'll see that there are large areas here of mostly sedimentary rocks, whereas any kind of volcanic rocks would have been here or up in little pockets in these areas here. So if you go to Central America today and you go to some place like Honduras, many of the Mayan structures, like here in Copan, are built of volcanic rock. So I'll show you some close-up examples shortly, but this is Copan as compared to Tikal, Guatemala, whereas this structure is made out of limestone instead. And you can see that this is a much lighter color, much whiter stone as compared to the volcanic stone that was used in Honduras. Similar comparison, here's a close-up of some of the stela in Copan, and you can see this is a large block inside of what is basically volcanic deposits of ash and pumice and what we call it volcanic tuff. Similar here in central Nicaragua, these are sculptures, Mayan sculptures that are carved from volcanic tuff as well, volcanic deposits. Where in Guatemala and Tikal, these are mostly made of limestone. And again, if you can compare the two, you'll see that they're different in their connections. An interesting thing is that today in Nicaragua, for instance, they still use volcanic rock, this volcanic tuff in construction. This is a large quarry where they use big saws to cut out bricks that then they use and cement together in order to build their structures. So with that, that's all I have. I'm happy to go and see what questions there may be. And
Well,
so, oh, sorry.
Dr. Jordan, that was fantastic. We do have one question that John Mangum posed. He said, "What do you think of Jerry Grover's book?" The book itself is entitled Geology of the Book of Mormon. There is a review in the Interpreter's Journal of this book. It's called The Great and Terrible Judgments of the Lord, Destruction and Disaster in Third Nephi, and the Geology of Mesoamerica. It's by Neil Rapley. Are you familiar with Jerry Grover's book?
Yes, in fact, I've also written a review of his book. And honestly, I think it's a pretty good book. I think it's well worth reading. I think he's coming from the perspective of many of us, again, because we don't know, we don't have specific low geography that we know of. I think that he actually does a pretty good job of discussing the Central American geology and geography and tying it into the Book of Mormon. Um, I don't agree with everything in the book, but I definitely think it's worth reading and a valuable resource. You know, if you're trying to study these things, just like reading the previous books on the what is it, the ancient America setting for the Book of Mormon, I think it's valuable. So I would say, yeah, I think Jerry Grover's book is worth reading for sure.
Well, let me ask you a couple of other questions. You listed a number of um, disaster events that are listed in Third Nephi chapter 8. We can't light fires. We've got, darkness. We've got lightning, uh, face of the land changing. Are you aware of any alternative explanations for the events that are listed there? You've made a good argument that these events can be described in terms of a volcanic event. Is there any other kind of natural disaster that you think fits?
Certainly. Well, I don't think there are, in my opinion, I don't think there's any natural disaster that is able to explain every single point described in Third Nephi, as well as a volcanic eruption. But as an alternative point of view, for instance, if you take the Heartland model, uh, individuals will talk about the large, what's called the New Madrid earthquake that took place in the early 1800s. It was the largest earthquake in recorded U.S. history, in which the Mississippi River actually flowed backwards for 2 hours. It was such a violent earthquake. However, that earthquake doesn't explain the mist of darkness in a way that you would have a vapor of darkness that you had also very dry wood that you couldn't burn. So although potentially you could have, there's this area of very large earthquake potential, it doesn't quite uh, cover that. In addition, people have talked about things like, speaking of a large storm, like a hurricane or a tropical storm. Some people have suggested that maybe it was similar to the Pinatubo eruption, where you had a large eruption coupled with at the same time of the arrival of a large hurricane or a tropical storm. And I think that's possible. The only issue I have with that is that if you actually had a tropical storm or hurricane occurring at the same time, then you wouldn't have dry wood. Everything would also be wet rather than dry. And so to me, that's why the volcanic explanation is a much better one.
Juliana is asking, is wind part of a volcanic eruption?
Yes, absolutely. Because the violence of the eruption is such that, imagine, just as kind of as a comparison, like we use leaf blowers to blow leaves. And the way that works is you're basically propelling air to flow in a direction. When you have a volcanic eruption, several things happen. Number one, the mag or the lava and the ash that's emitted out of the volcano is going to create very rapid flow of the atmosphere upward. And as that goes, it actually pulls in the air surrounding the volcano into very strong updrafts. Those updrafts, though, have to be fed from the sides. And so then you get very strong winds that will actually flow towards the volcano, oftentimes very violently. But then the pyroclastic flows, as they collapse and rush down the sides of the volcanoes, those as well are going to be basically creating very powerful atmospheric currents that can generate things potentially like tornadoes or just very strong winds that literally can blow people away.
Wendy's wondering what kind of injuries would be common for people who survived these kind of events.
Well, there would be a lot of blunt force trauma if you were in a building that collapsed under the weight of the ash. You would have broken bones, head injuries, most likely. bruises. You probably have things such as lacerations, cuts. If you were not inside of a building and you were caught in one of these whirlwinds, or you were caught in the landslide or one of these mud flows, again, same thing, blunt force trauma, lots of debris that would cause serious injuries. But if you were really close to the point where you're getting the heat part of it, such as a pyroclastic flow, severe burns. You'd have second and third degree burns. That's often what kills a lot of people. Is it's the heat that they basically are killed from the heat, the high temperatures from the pyroclastic flows. But yeah, lots of blunt force trauma, lacerations, and burns.
You mentioned the Heartland model a couple of times. In the central and northeastern portions of North America, has there been any confirmed volcanic activity within the last, 3,000 years?
There haven't been any in the last several million years. If you look at the geologic history of North America, moving east of the Rocky Mountains to the east coast of both Canada and the United States, it's very, very old geologically, or relatively old geologically, for any rocks that would have been volcanic in nature. You have more recent sedimentary deposits, but as far as volcanic deposits, I'm not aware of any that would be younger than several million years.
You also mentioned Lake Atitlan as an example of a geological feature that is left behind
Caldera,
from
yeah.
volcanic activity. Are there other evidences of past volcanic activity that we might expect to see during our tour that might correlate with events described in Third Nephi?
I'm not sure exactly where you're going to be going on your tour, but as far as the volcanism goes, if you're going to Teotihuacan, for instance, a
We
lot of the
are.
rocks, yeah, so a lot of the rocks there that those buildings are constructed out of are going to be volcanic, because that's right very near that central I'm trying to remember the name of it, the southern Mexican volcanic belt that runs through there. If you're in Mexico City, you're going to be right next to Popocatépetl, Mount Popo, as they call it, which is actually considered one of the 10 most dangerous volcanoes on Earth, because Popo is still very active and has the potential to erupt catastrophically. And in fact, there are something like 25 million people that live within the danger zone around Mount Popo. So if it does erupt catastrophically, how do you evacuate 25 million people? I spent some time in Puebla on the opposite side from Mexico City of Popo. I was there for a research conference, and it was fascinating there because there were places where we would go into streams, where the stream had cut down through the volcanic layers from Mount Popo, and those layers were just chock full of Mayan pottery and other artifacts and things that were just there, just right eroding right out of the riverbank in these volcanic deposits from that volcano.
Along those lines, Marianne asks, what are some of the warnings given before an eruption?
Well, hopefully we're getting better at this. Volcanoes are probably better than as far as prediction goes compared to things like earthquakes and stuff. But typically, when a volcano is about to erupt, you'll typically have an increase in earthquake number, not necessarily in violence. Although in the case of, say, Vesuvius and Pompeii, there was a very large earthquake that took place a few years before the major eruption. But typically, you have an increase in earthquakes, like basically lots of them, what we call an earthquake swarm, because those earthquakes are generated as the magma is rising towards the surface. The pressure from it is literally breaking the rock as it's rising, and so as it does, those little the breakages create swarms of earthquakes. So that's one of the things that modern volcanologists will monitor to see, is there an increase in the number of earthquakes. You also get an increase in the amount of gases that are coming out of the volcano, because that magma that's rising, since it's fresh magma rising from where it was generated where the water from subduction created it. It's now basically a fresh batch of magma with with it's more saturated in gases that will then start to degas and come out. And so you'll get an increase in the amount of gases escaping. And then the last thing is that the surface of the earth above the rising magma, the volcano itself, will actually, its elevation will start to shift. It'll start to rise because of that magma that's rising will lift the surface. And so those three things together are usually heavily monitored to predict changes. But oftentimes, for instance, the swelling of the ground, you need sophisticated instruments in order to measure that. Someone just on the surface isn't going to notice it. So for instance, the Nephites, if this really happened and it really was a volcanic eruption, it's very unlikely that the Nephites would have noticed anything, maybe some earthquakes. But for example, when Mount Pinatubo erupted in the 1990s, there was no warning. There was no noticeable warning at all from just people. The mountain just started to explode one day. But to be fair, there were no modern instruments of monitoring of it because people thought it was actually extinct. They didn't even think it was active anymore, which also brings in the idea of, well, why didn't the Nephites talk about volcanoes more? Well, the average interval between volcanic eruptions is about 2,000 years. Most people, when they think of active volcanoes, they think of Hawaii or say Vesuvius or places in Italy like Mount Etna. But those are anomalies. Most volcanoes do not erupt, even though if they're considered active, they still don't erupt, except every few hundreds or thousands of years.
Well, I'm sure you could go on all night. This has been fascinating
Yeah.
and such a great preparation for us for this tour. Thank you very much, Dr. Jordan, for your time and for sharing these thoughts with us.
Well, I'm happy to. I could talk about volcanoes and the Book of Mormon, not necessarily the two together. I could talk about both for a long time. I enjoy it.